Well, hello and welcome YouTube. Mr. Robinson back here with yet another brand new exciting video, all math-based of course, and as always, it is an honor and a privilege to have you step into my virtual math classroom as we learn all math-based sorts of stuff here. Today is actually a Q&A video, and it's based on certain topics. We're doing them based on integer arithmetic and solving two-step equations. Now, Q&A video is a little bit different from my other ones because it's based on you, the people who actually write the questions for me that I then choose to answer for you. And if you're watching from the outside in, if you're not actually in one of my classes, maybe you learn some material here and there. But the kind of kicker about the live stream videos that I'm going to do in the future, and I actually wanted to do tonight, but I was not able to, is I plan on actually doing live stream videos with them. And it's actually going to be a nice fun format because I get to interact with people as they're watching it live. Maybe they have other questions that they want to ask along the way in the live chat section, and then I can answer those ones at the very end of the video, and then just things come to fruition there. Now tonight's a Tuesday night. Generally, if I do a live stream video, I'm going to probably do it on the Sunday late afternoon. Because it's football season, I'm going to wait till the afternoon games kick off, like the Niners and such, and then I'll probably get those started around 4:15, 4:30 before the Sunday night football game then kicks in, and then I'll get that live video out of the way. So that'll generally be what it is. So I tried to do a live video thing tonight. Couldn't get the kinks worked out when it came to some technical difficulties, things with audio mic delay and just quality. It was kind of strange. I've never done a live video with it before. When I get it worked out, I think it's just going to come to fruition very nicely. And of course, I'm always trying to build the channel. So I'm trying to find ways to get this a little more technologically savvy, have it a little more interactive and fun. Because, as you know, math isn't always the most fun thing, but I like to think of some parts here being fun and invigorating. So without further ado, let's go ahead and let's take a look at what's going on here. We are looking at integer arithmetic and solving two-step equations. You can look at all 6 questions here, but when we go to actually do the questions, you'll see them nice, big, and bold. Well, maybe not bold, but they're going to be nice and big then and there when we're doing it. You can see that 3 are kind of based on the integer-based portion here, and then 3 on the solving two-step equation stuff here. A lot of things to do with calculation things in general, because, you know, we're doing a lot of things without a calculator, and we want to make sure that people know how to do things in a mental sense, not because it's required, but so they're feeling very confident about the things that they're applying without having to rely on the calculator all the time, or when they're not quite sure if they're doing the inputs with calculators correctly. Case in point, order of operations, if you're not doing them right in the calculator correctly, they won't give you the right answer, and it's good to just know how it's done in general. It's very fun to be able to do mental math anyway, but some of these questions are more involved in the realm of perception. What you're able to do or not when it comes to negatives, when it comes to fractions and decimals, and all that kind of stuff. And those are the questions that I picked out for a very specific reason. It seems like those are the ones that people tend to have the most trouble with. The basic stuff they can kind of do okay with when it comes to these sections. It's when it gets a little more complex that they need a little more help. And that's totally fine here. Now, these questions, like I said, are asked based on my students. And how do you get a question asked on here? Well, it's really quite simple. If you're one of my students, what you would do is you're given an assignment sheet from me, and then at the end, when I collect these assignment sheets after, I think, 2 weeks from you on that Friday, you had some questions written down. 1 to 3 questions. I take a look at them. I'll personally answer it on your sheet right here if I feel like it's something I can just get out of the way. It's something that's nice, but if it's a very nice question that can diversify these kinds of videos, I'm going to look to get up to 10 of them, and 10 isn't like I want to hit that quota each time. 10 is just the maximum. So I chose to look at 6 here that are best to be answered on here, and that's totally fine. It doesn't need to go up to 10. Doesn't mean that there were 4 others that I couldn't find. It just felt like this covers everything that really needed to be covered in this nice, broad brushstroke. And, you know, if the minimum I'll probably try and do is 5, unless I do feel like that there aren't questions that are worth asking. They must relate to the topics that are being covered within the weeks that we are looking at them. And, of course, when I get the live chat section up, you can ask a question then and there, and then I'll try and answer it at the very end of the video with it. And if you get your questions selected based on these things here for the students, they get a nice little extra credit point along the way. I think that's a nice incentive for them to try and get the questions that they feel are not only worth it for a video, but are worth it for them. You know, it's something that they can just make happen and enjoy saying that, hey, that was my question. I got it answered. Maybe it wasn't the way I wanted it to be answered, but that's okay. That's the way Mr. Robinson rolls. So without further ado, let's go ahead and take a look at our questions here. And the very first question of the video is going to be asked as follows. When multiplying and subtracting integers, how do you know if the result is negative or positive. Now, you might have seen the first question that was asked on here, or excuse me, the second question that was asked on here as well. It's going to be kind of in the same vein, but I promise you they are two different questions, and I'll try and answer them in two different ways. I'll lead this one into the next one a little bit. So let's just look at the multiplying portion first, because it is significantly easier to talk about, and here is the way that I'm going to mention it. A negative times a negative equals a positive. A negative times a negative equals a positive. If you've seen the movie Stand and Deliver, then you very much know that saying from Jaime Escalante, as he says, a negative times a negative equals a positive. So when you pair up two negatives together, that final result is positive, and of course, a positive times a positive is a positive. So how do you get a negative result when you multiply? Well, that comes from doing a positive times a negative. A positive times a negative gives you a negative, and then of course a negative times a positive also gives you a negative. Because multiplication is commutative, I can reverse these two things and it works out. So for example, 3 times negative 2 equals negative 6, and negative 3 times 2 equals positive 6. It doesn't matter where the negative's applied, as long as it's just one of them, it works. So if you had a string of multiple values, if there were like 5 things multiplied and some of them were negative, some of them were positive, and I'm going to talk about this with the subtraction portion as well. What are things you can do? One thing is you can just do one set of multiples at a time. There are 5 things multiplied, just multiply these two first, get the resulting number and sign, and then multiply this number with this one, get that result, and this one with that number, etc. Just pair up over and over if you'd like to. The other opportunity you can do, and normally when you do the multiplication, yeah, I would probably still do one number at a time multiplied. If it was like 2 times 3 times 4 times 5 times 6, I would do 2 times 3 and then 3 times 4, something like that, right? But as far as signs go, if it was negative 2, here, let me write this. If it was negative 2 times positive 3 times negative 4 times positive 5 times negative 6, you can really, instead of just doing the one at a time for the signs, you can really just look at how many there are negative, and if that number is even or odd. So there are 3 negative numbers here. Now, how does that help you? Because if a negative times a negative is a positive, and then there's a third negative that comes into play, that's a positive times a negative, which gives you a negative. If you have an odd number of negatives in your multiple, or in your fraction, by the way, if you're dividing, that's the same thing as multiplication when it comes to signs. If you have an odd number of negatives, your result will be negative. And if you have an even number of negatives, all those pairs will cancel each other out to give you a positive set. So when I'm looking at this problem right here and we're doing it, I know that my result's already going to be negative because I have 3 negatives multiplied with the other 2 positives. So the result I know is going to be negative. And when you multiply it out, I kind of like doing the 5 times 6 first because that gives me 30. And that's nice to kind of multiply things with. 30 times, let's do the 2 times 3 is 6. 30 times 6 is 180. 180 times 4 is 720. So negative 720 would be that result, for example. But anyway, so the negative comes into form with counting the number of them. Odd number of negatives gives you a negative result. Even number of negatives gives you a positive result. That's for multiplying and dividing. Now, subtracting integers. And they didn't specifically say adding. Adding a negative would be subtracting. So let's just assume we're talking about subtracting. When you're subtracting, how do you know if the result is negative or positive? Well, I think you've done enough subtraction to know when it becomes positive. And if you think about that answer, then that kind of helps answer for you when you know it's going to be negative. So when you get a positive result from subtraction, give yourself a subtraction example. Let's do a couple. 11 minus 4 gives you a positive. 5 minus 1 gives you a positive. 90 minus 18 gives you a positive. The thing that brings all of these together is not even, odd, or anything like that. It's big minus small. Big minus small gives you a positive number. If I have this much money to start, and then I lose this much money later, a smaller amount, then I'm still in the green. I still have more money than 0 or negative. I'm not in the red in any sort. So, these would all give you positive results. Now, how do you get a negative result from these? Flip it. Do small minus big. If you do 4 minus 11, 1 minus 5, or 18 minus 90, now you know that your result's going to be negative as a result. And in my long 45-minute video on how do you subtract and stuff, there's a little bit more I can tell you on how to get the actual number. But that's one way you can know your result's negative. Now there's another way, and that is if your first number that you have is negative before the subtraction. So if I have something like negative 5 minus 1, it doesn't matter that the first number is bigger or smaller because that first number is also negative. So if I have a negative and then a minus, and this goes to that 45-minute video again, I'm going left and then left again. And that'll just get me further into negative territory. So there are two ways that you know that your number's going to be negative through subtraction. Either when you're doing small minus big, or when your first number's already negative to begin with. It doesn't matter if they're big or small. Negative 5 minus 1, negative 1 minus 5, they're both negative 6 as an answer. Oh, or if you do 0 minus something, 0 minus 7, that's also negative. Which I don't know if you call that small minus big, and that 0 is infinitesimally small, and that it is just 0. There's nothing there. And also, if you do a number minus itself, that answer is neither positive nor negative. It's just 0 as well. So hopefully that kind of just wraps those two things up when we're looking at that. When you're multiplying or dividing, negative times a negative is a positive, and an odd number of negatives within your product or your quotient is actually going to give you a negative value. When you're subtracting, you know it's going to be positive. You've seen them before. You know when that's going to be big minus small. So small minus big will give you negative. 0 minus any positive number will give you negative. And then negative number minus will also give you negative because it starts negative and just goes further negative. All right. Excuse me. So that ends up just being the result of those. That was a very good question that was being asked because sometimes the negative is just forgotten. And you can do anything you want. I can ask the question a million times and I'll always get an answer where people disregard the negative when it comes to an answer. If I say, what's negative 3 minus 5? They're thinking in terms of the calculation, what do I got to do? Their first inclination is to say 8. But you have to keep in mind that that negative is still there. So one thing that I would do first is, that question is important because it comes to anticipation. Should I anticipate a negative answer before coming with my number? Yes. So it's not forgotten. And if you're writing it down, I would just write that negative sucker first before doing anything else. If I know it's negative, write it down before you forget it. Or think about it and say, I know the answer is negative. Now let's do the calculation. Oh yeah, remember the answer is negative, and let's do that. So that's, I think, where I'd go with that problem, and I think that that's what makes the most sense to me. All right, so let's go on to the next question. And the next question asks this. What is the easiest way to know rules computing integers with negatives and subtraction? So hopefully you get a little bit of gist on what the difference is between this question and the other. One rule that we can talk about is whether you know what thing's going to be positive or negative with the signs, but now this is more in terms of the computation. I gave you 1 minus 5, and it's great for us to be able to figure out what the answer is going to be as a result. Now, I have a 45-minute video on this, and I'm not going to explore this, so I'll just go ahead and talk about it in a nice, decent nutshell here. And it's not just the 1 minus 5, it's other versions. And I've done this with other ones. Let's do 5 plus 1, 5 minus 1, and negative 5 minus 1. Stuff like that. So what's the difference with all these four? And this isn't really subtraction, but just the idea of, here's a negative with subtraction, for example. But with addition, you can tell that as we start positive and go further right, then it's going to stay addition. But when you have something like subtraction like this I talked about, you start left and you go further left. So the rule with something like this one that I would dive into, and again, the idea is both of them are negative, kind of, the negative and the minus. So you go left and left. I say treat it like addition. Just like 5 plus 1, treat it like 5 plus 1 because you're going further in the direction that you are, so you know your number is going to be larger. 5 plus 1 is 6. Negative 5 minus 1 is negative 6 because it's like 5 plus 1, but as I said before, anticipate the negative answer, you know the result's negative with it. So as long as the signs are the same, the numbers are just going to get bigger in their respective direction. So with negatives and subtraction in that form, I would say go ahead and just treat it like addition, but know your answer is negative. Now the other version that we were looking at are these two right here. 5 minus 1, we know the answer is 4, and 1 minus 5, with 5 minus 1, just going back here quickly, 5 is positive, 1's negative, sort of, you're subtracting 1. So they're opposite each other. So you know that number gets smaller as a result. We go right and then we go left. So the 4 is the result, it's smaller than 5. So same with this one, 1 minus 5. 1 is positive, 5 is negative. Go 1 right and then 5 left. You're going 5 left of 1, not 5 left of 0. So our number is going to be a smaller value, like closer to 0. It's going to be negative 4 in this case. 1 minus 5 is like 5 minus 1. In that, because the signs are opposite, it's like a subtraction. Because the signs are opposite, it's like a subtraction. But, as I said before, anticipate a negative answer because you're doing small minus big. You're subtracting a bigger number from the smaller number that you have. So that's how I deal with those things. Now, if the question was asked more in the form of negatives and subtraction, like 5 minus negative 1, well, this becomes addition. Subtracting a negative becomes addition, like 5 plus 1, and that gives you the 6. And how do you do that, or how do you treat it? I would literally do that rewrite every time. So that's that 45-minute video in a nutshell. The 45-minute video wasn't just telling you how to do it. It was an exploration and guidance so that you could have a way of making sense of everything, connecting all the dots. So hopefully that kind of resolves question number 2 when it comes to it. So again, to recap, when you have numbers that are of the same sign, it doesn't matter about the plus thing if that wasn't a part of the question, but because they're both positive, the numbers get larger. Because they're both negative, the numbers would get smaller as well. They would get larger in the negative direction. So you treat it like addition. And then when you have some sort of things that are opposite signs, you treat it like subtraction. 5 minus 1 or 1 minus 5 will shrink closer to 0. 4 and negative 4. The next part about it, of course, is anticipate whether your sign is negative or positive based on negative minus, obviously negative, and small minus big, also negative. The rest should be positive or 0 if you're subtracting one with another there. All right, let's go to the third question here. And the third question asks the following. Why is multiplying and dividing integers actually easier than adding and subtracting them? And I know that kind of sounds like a weird question for a lot of you guys because a lot of you guys grew up learning addition and subtraction first. You were in kindergarten, first, second grade, whenever it was, you learned addition and subtraction first. You claim this must be easier than multiplication. And by and large, look, if I'm doing 538 plus 192 instead of 538 times 192, I think I'm going to go with the addition with that. What we're talking about, though, is just with the integers, with the negatives and the positives, why are the rules for multiplying and dividing so much easier, provided that we're not talking about weird fraction answers? You have to long division, or that we're not doing huge triple-digit multiplication. So now, why is this? Okay, well, this isn't something I really got to write anything out with, but the reason really is this. We talked about the question number 1, what the rules are for multiplying when it comes to negatives, and the rule is very simple. A negative times a negative is a positive, and a positive times a negative is a negative, all that. That's all you just know the Jaime Escalante stand and deliver line, and negative times a negative equals a positive, and you're done with the sign portion. There's nothing else you have to do with the signs with that. And the multiplication that you do isn't affected by the signs of the things when it comes to getting the value. See, 5 times negative 3 is still going to have a 15 in the answer, whereas 5 plus negative 3, that's no longer necessarily 8, and in fact, it's not 8 when you have it. So the value changes, and that makes it a lot harder. That's number 1. Number 2 is this. You've been doing multiplication, times table multiplication, with a lot more practice and steadfastness than you have with addition and subtraction. Bear in mind, I think you know that 12 minus 8 is 4. You've probably been doing 12 times 8 as much. I don't know how much you guys have been practicing your 12s, but your times tables up to 10 and 12 and stuff have kind of been ingrained and grooved since 3rd grade. And they're the numbers that you really get familiar with. You do the times table so often that it really is such a different familiarity than that of addition and subtraction. Whereas addition and subtraction, you are really, 5 plus 7. Sometimes people actually count it. They don't memorize it in the same way because we do so many more addition and subtraction things. We'll do 48 plus 5 more than 48 times 5. So our addition subtraction is really just carrying through the computation. And multiplication and division is through rehearsed muscle memory. It's good habits that came into play. The smaller ones, right? I'm not talking about those bigger ones. Those bigger ones you're going to have trouble with as well until you learn more multiplication or do the column multiplication. But that's kind of why you grooved yourself with that, number 2. And then number 1 was the signs. The signs aren't going to affect the value. So with the addition and subtraction stuff, they really do get a little clustered. When I get negative 3 minus negative 12 and get the up, it gets really strange. And I acknowledge that as well. It gets strange. It does, and it gets a little bit harder to do. But that's kind of why, going back to this question again, that's kind of why the multiplication and dividing. And look, I didn't mention dividing yet. Dividing is just, when you do 72 divided by 8, you might ask yourself 8 times what gives you 72. So you're going back to multiplication when it happens. But you've probably practiced the division enough, and you will a lot more with the algebra, to go I just dropped my pen, to go it's a breeze. It's steadfast. It's really just something that you can do very, very quickly as a result. Let me grab my pen. So that kind of answers the question to me. And I really like the question. It's picking my brain and say, this might not be true for everybody. Not for second graders, but once you do it enough, I think multiplying and dividing just becomes easier with those integers because the rules aren't as picky. You saw the rules in question number 2. You literally just saw them, and they do get a little bit more hectic as you go. All right, I always promise myself these videos won't get long, and then they do. So I'm just going to go and speed up. But those were the integer-based questions. And with these other ones, I do have to probably do several examples along the way. So let's just go ahead and do them. And so question number 4 is going to be asking us this. How do you solve an equation that involves decimals? Keep in mind, the person that asked this, we haven't done decimals yet, but it is involved in our topic. Because our topic's going to involve fractions. You can convert a fraction to decimals, and you can bet that decimals are going to pop up here. In fact, there was a decimal question in the homework textbook. I had them skip it, but I think it was this. I think it was 3x plus 0.3 equals 3.3. Now, there's more than one answer to this question. One way to answer it is suck it up. Decimals happen, and there's a way to compute them, and it's really just lining up the decimal when you do a subtraction. So look, let's solve this problem together. I can subtract 0.3, that constant, from both sides. As long as I line this decimal up, subtraction goes the same way as anything else would. 3 minus 3 is 0, so that's 0.0, and 3 minus 0 is 3. So that number over there is 3.0, and over here I have 3x. Now, 3.0 really is just 3, so I could just write that as 3x equals 3. And look, sometimes the decimal goes away, and that is beautiful. And then you solve and you get x equals 1 if you end up dividing by 3. Great. So how do you solve an equation? You do it like you would any other one, really, if you want to. How do you deal with it? Suck it up is one way. A calculator is another way. Sometimes when we do these ones, I mean, look, the algebra that we're doing here is cleaner math. Like, I think they're going to give you those a lot more. But I can give you one that's a little trickier, and then I'll give you another version on how you can actually do them. And because one thing that we don't like about decimals is the perception. One thing I do like about decimals is you can make it look like money if you can get to 2 decimal places only. Not that I want to do a problem like that right now, but let's go and do another one. Let's try this one. Let's try 8.1 minus 2.4x equals 0.9. I'm going to make everything here decimals. Now, in this particular instance, I'm not going to have us deal with the whole suck it up fashion and line the things up. I want to give you kind of another way that's going to work out, and I think it leads into one of my next questions involving fractions, so I do want to do it. The truth is, and the cool thing is about equations, no matter what you do to one side of the equation, you can do anything you want to one side of the equation as long as you do it to the other side of the equation. Keep it balanced. I can wipe a booger on one side of the equation. As long as I do it on the other side, the same amount of booger, it keeps it balanced. The point is, I'm weird. I can make these things not look like decimals anymore if I'm willing to deal with the consequences of what comes with not having decimals, and as long as I don't make a mistake doing it. Here's the cool thing with decimals, and you might not know this as well. Did you know that 4 times 10 is really just 4 with a 0 on it? And I think most people know, like 4 times 1,000. Well, that's 4 with 3 zeros at the end. People just say, I'll keep the number and do the multiplication and just add the zeros. And that's true. But it's not just zeros that are being added. It's a decimal shift that's being applied. If I do 8 times 2,000, you think of, let's do 8 times 2 and that's 16 and add the zeros. But it's also this. It's 8 times 2, but then times 1,000, it's taking this decimal that's right here and it's shifting it 1, 2, 3 decimal places. That's where the zeros come in. And then that decimal here, of course, is gone. And then you have 16,000. Now, why do I bring this up? Because if you multiply your equations here, your expressions in your equation, by powers of 10, any power of 10, if I multiply something by 10, I can right shift my decimals once. If I multiply by powers of 100, I can right shift my decimals twice. 1,000, 3 times, 10,000, 4 times. All of these have a decimal that's only one place over here. If I multiply this side of the equation by 10, and I ideally distribute the 10 into the 8.1 into the negative 2.4x, what I get is a decimal shift right here, and a decimal shift right here in my values, and this turns into 81 minus 24x. I've actually cleaned up my equation free of decimals on the left side of my expression, and there are no decimals anymore. Now, I can't just set it equal to 0.9. That's unfair. I multiplied this 10 times larger, so I have to do it to the other side as well. If I multiply this side by 10 as well, 0.9 times 10, it sounds, for some people, it sounds like a little bit of a challenge, but it's just a right decimal shift. I go ahead and right decimal shift this 0.9 over. Here's my new decimal. So the value is just 9. How does that equation look? The numbers are bigger. I acknowledge, look, the numbers are bigger. I get it. but there aren't decimals. You're rid of decimals, and if that's your goal, how do you solve one that involves decimals? Get rid of them. There's a way to, so don't deal with it. Literally, don't deal with it. Deal without them. Find a way, a coping mechanism making it happen, and you can. So if I subtract 81 from both sides, I'm going to get negative 24x equals negative 72. And I divide by negative 24, I'll get x equals 3 for that. Whoa, you can't see me because of the screen. You get x equals 3 on that particular problem right there. So, so there are ways that you can go about dealing with the decimals there, and one's the multiplication thing, the other's dealing with it. I'll talk about that with fractions as well, but that's kind of the idea. You can line up the decimals and work that out, or you can multiply by a power of 10 and do a certain shift and make them go out of the way, with, of course, the caveat of this. The numbers will get bigger. There are other ways that you can do, not decimal shifts, but multiply by numbers that can clean them up sometimes. Not this one, but there's some other ones. If I multiply by 5, it might clean them up. It depends. But you have to be really, really crafty and know what you're doing with the multiplication before it happens. But trust me, even I do it too. I'll do anything to make solving my answer easier if it will take just as much time to solve or less. Or if I'm teaching it, of course. All right, so that was question number 4. Let's go ahead and move on. We have 2 more questions here. Let's move on to question number 5. And this question is this. How do you check your solution to an equation that involves fractions? Now, I don't know if they mean, when they asked this question, I don't know if they meant the solution as fractions or the original equation itself as fractions. And generally, I think we're talking about, there's a fraction probably in the coefficient. So if we're talking about something like 2/3 x, and I'm making up an equation right now, 2/3 x plus 4 equals, let's see, I want this to work out. So 2/3 x plus 4 equals 16. 2/3 x plus 4 equals 16. Okay, this one involves fractions. Let's go and solve it. Subtract 4 from both sides. Actually, you know what? I don't want to do this kind of problem just yet because I don't want to tell you how this part works before we get to question 6. Let's do 1/3 x. 1/3 x plus 4 equals 16. Subtract 4 from both sides. We get 1/3 x equals 12. And 1/3 x is the same thing as x divided by 3. So if you have trouble with that, you can reperceive it that way. If we're dividing by 3 here, we can multiply both sides by 3 to get that solution, and we get x equals 36 in this particular scenario. Now, how do I double check my solution? How do you check your solutions to equations that involves fractions? How do you double check your solution anyway? That was actually one of the other questions that was asked of me in my thing, so I decided to just answer it with this one as well. How do you double check a solution and make sure that it's right? You substitute it back into your original equation and make sure that it works from there. So here's how I would do it. I would rewrite this equation completely, except I'm going to substitute 36 for x. And when in doubt, for those who know, you should use your damn parentheses when it comes to substitution. 1/3 times 36 plus 4 equals 16. How do I even deal with this fraction? Well, here's the thing. Because some people aren't sure really how the fraction works. Some people think 36 multiplies with both the 1 and the 3. Some people think that 36, you do cross multiply. So I'm not going to talk about that. Really what you do is 36 is really the same as 36 over 1. 36 divided by 1 is 36, so I could rewrite this thing as 36 over 1. 36 over 1. Now, the way that that helps me is when I multiply. See, when you multiply fractions, you multiply straight across. 1 times 36 and 3 times 1. Excuse me. So when I multiply that one straight across, 1 times 36 is 36. 3 times 1 is 3, so I have 36 divided by 3 on that portion. I'm sorry, you can't see that. I know that my face cuts it off right there. 36 plus 4 equals 16. And then 36 over 3 equals 12. 12 plus 4 equals 16. All that, yada, yada, yada. Now, you can also do a division here. 36 divided by 3, if you know it straight up, before you do any fraction reductions. There are a lot of things I can do with that to work with it. I might have some videos on it. But that's one basis there. That's one way. And then the other way, of course, is if you get a fraction as an answer, you can double check using the same method. Let's go ahead and take a look at one of those. And then I'm going to move on to question 6. And we'll get you on out of here. So let's do something like 7x minus 9 equals 18. And then 7x, add 9 to both sides, 7x equals 27. Divide both sides by 7, x equals 27 divided by 7. Kind of a weird answer. I can't simplify it. I can't reduce it. I'm going to leave it like that. So how do I double check that solution? Again, it's a substitution. I'm going to rewrite this 7 times 27 over 7 minus 9 equals 18. And I could have found other ways to make this harder. But the same kind of thing is going to happen. 7 is really 7 divided by 1. This time I'm not going to write it, and I want to see if you can pay note to this. 7's going to multiply with the 27. It's not going to multiply with the 7 here. But it is going to multiply with the 27 in such a way that, look, I don't want to do that multiplication if I don't have to. If 7's going to multiply with 27, and if 27's dividing by 7, why can't I just write it like this? And you might be asking, why would you write it like this? Because this might give you a better idea of making sense of the fact that this 7 is actually still dividing by this 7 right here, and these become 1. 7 over 7 is 1, so you're left with 27 minus 9 equals 18, and then 18 equals 18, and all checks out. So, I mean, the way that you deal with fractions is, number one, an integer multiplies with a fraction in such a way that the integer actually multiplies with the numerator on top. Okay. And then the over 1, you can make it as 1 multiplies with the denominator, and you have that. But another thing you want to keep in mind is that if you can divide any part of the numerator with any part of the denominator to clean things up, by and large, go ahead and do that, because making numbers smaller is easier than making numbers bigger. I don't want to do 7 times 27 and then take that and divide it by 7. But if you're smart about it, if you see that, oh, I multiplied by 7 and then I divided by 7, I'm back at 27, that, but that's a specific example. Another one that we didn't do is if you have a fraction times a fraction when it comes to substituting. You have a fraction as your coefficient, and then you have a fraction answer. You multiply top with top and bottom with bottom. But the way you double check is you substitute it in, do the multiplication with the coefficient, and then you're on your way. And that's how you do any sort of double checking with the solution as well. Substitute, and when in doubt, use your damn parentheses. That's, of course, Mr. Robinson's motto, as you know that. And let's go on to number 6, where I'm 30 minutes into this. I do feel bad when I do these things. I always try and find ways to reduce them. And I can't. I'm a talker. That's just the way that this thing works. So let's go to the last question. And the last question is this. If we have an equation with a fraction coefficient, do we just apply the inverse operation of its denominator? Now this goes back to the last question that I just had. It was 1/3 x minus 4, plus 4 equals 16. And you saw me subtract 4 from both sides, and then the whole, I said at this point, notice that 1/3 x is the same thing as x over 3, and it is in the same way of the other things that I just talked about. X is in the numerator, x times 1 is x, and you have x over 3. So the question is, when you have a fraction coefficient, do I kind of just multiply both sides by 3? Let me get myself on the thing. Do I kind of just multiply both sides by 3? In this case, yeah. As you can tell, you multiply both sides by 3, and Bob's your uncle. You're set. All's good. You don't even need to write this portion right here. You can just multiply both sides by 3 here, and 1/3 of 3 is 1, and you're good. X equals that 12 times 3 answer. So yeah, that is one way that you can go ahead and do those answers if you want to do that in that particular one step. Now there's another particular problem type that I wanted to jump into, and let's go and take a look at it. It's, and I was writing this before. Let's undo some of these. I was writing this before with a 2/3, because this kind of changes things. I mean, in a not necessarily a big bad way, but it does change your idea and perception on different ways you want to solve this problem. And the question really becomes one of two things. And I can find multiple ways to go and do problems like this, and I want to run into all of those if I'm able. Number one is, do I want to spend more steps than normal? This is rhetorical, something you can answer based on the question. Do I want to spend more steps than normal? Number two is, do I have another way of knowing how to re-perceive this question if I need to? Number three is, do I want to get rid of fractions entirely to begin with? Remember the decimal thing I talked about? I'll show you that. And number four is, do I understand how to divide fractions? So there are four different questions you can ask yourself. If you know how to answer any one of those is yes, you'll have a way of solving this. But to answer the question, do you just multiply the inverse operation of, do you apply the inverse operation of the denominator? Not here. It's not just the inverse operation. It's applied at some point, but it's not the only thing. So let's look at it at the way that it's asked. Let's subtract 4 from both sides, and we have 2/3 x equals 12. Do I just do the inverse operator of this? If I'm dividing by 3, do I just multiply by 3? Well, that's part of it. And if this is one step you want to do, great, because 3 divided by 3 is indeed 1. But look at this. I still have 2 times x right here. So 2 times x equals 36, and I still have another step to go. So do you just apply it? No. Is applying it a part of it? Yes. But now you still have this part as well. And if I divide both sides by 2, I get 18 as this new answer. And I can double check that. I'm not going to. But I could double check that one. And then all would be good. But that's one way I could do it. It's a two-step way. And all the other ways that I kind of do this is going to kind of be that two-step, not two-step way. This is 3 steps. But this portion took 2 steps instead of 1. So another way of getting to that part again, 2/3 x equals 12. If you have trouble identifying with the fact that you can multiply both sides by 3 on this step, You could do that whole, hey, 2 times x, I can write that as 2x right here, and all of this is dividing by 3. Some people have a better idea of looking at this and saying, this whole thing is dividing by 3, so if I multiply by 3 on this step, it's the same thing as the previous problem. But if I multiply by 3 on this step, then that does get rid of the fraction at this point. I think some people see that a little bit better. Again, perception's everything when it comes to math. People can see that and go, all right, I'm good there. And then I divide by 2, and Bob's your uncle. You're back at the same thing you were before. Here's another alternative, and it goes back to that decimal thing. You have a question with fractions in it, and you just hate fractions. It doesn't matter that fractions aren't involved until the very end. You do not want to deal with fractions anymore, just like the decimal thing. The cool thing about decimals is you can multiply by powers of 10, like 10, 100, 1,000, yada yada. With this thing's not quite as easy. It depends on what the problem is. This one's not so bad. You can see that a single number is divided by 3. So if something is divided by 3, you can say, what if I multiply, just like multiplying everything by 10, what if I multiply everything by 3? What if I do times 3 and times 3 from the beginning? If you do 3 times this number and 3 times this number and 3 times that number, fractions will go away because 3 times 2/3, you've seen it a couple times, is just 2. Or 2x in this case, is just 2x. So they cancel out with that one, they become 1, and 3 times 4 is 12. This step might be a little bit harder for some of you guys to do. I'm just presenting you the option if you have it. And I know it's not a part of the question, I know it's not the question that's being asked really, but it does kind of answer the question that's being asked because this is something you can do. Does it just apply the inverse operator? No. But you can find the steps this way and you can solve get x equals 18 here as well. The numbers are bigger, you have to find ways to do it, you have to know what distribution is, and you have to not mess this portion up. But it's possible. And here's the fourth way. Let me wipe all these things out. The fourth way is this. Let's write that out again. Last question. We're almost done. All right. 2/3 is multiplying by x. 2/3 is actually my coefficient, and I like that this is being used. Coefficient, the number that's multiplied in front of x. It is 2/3. If this said 2x equals 12, you would divide both sides by 2. If it said negative x equals 12, you would divide both sides by negative 1. If this says 2/3 x equals 12, you would divide both sides by 2/3, I guess. But what does that look like? Divided by 2/3, divided by 2/3. What the heck are we doing? What is going on here? Well, dividing by a fraction is the same thing as multiplying by its reciprocal. And I know that I say that I don't like to do the division sign very much for fractions anymore, but this is one case where I think it actually holds pretty well. If I divide both sides by 2/3, divide by 2/3, I'll just write that again, those cancel, it becomes 1, but on this side, I could write it this way, divided by 2/3. Why does this help me? Why does left to right help me? Because dividing by a fraction is multiplying by a reciprocal, and if 12 is 12 divided by 1, I can treat this as 12 divided by 1 times the reciprocal, 3/2. I take the divisor, and is it the divisor or the dividend? See, I don't even know, I'm a math teacher. I take this guy and I flip it, and I multiply that way. And this goes back to the same idea. If these are all multiplying, I don't have to do 12 times 3 first. I can do 12 divided by 2 first, turn that into 6. And 6 times 3 is 18. And that would be my answer there, x equals 18. That's kind of weird steps that we wrote to make that happen. So if you just want to see this again, kind of a nice cool way about this that makes this work kind of like in a snap instant. You still have to multiply this part. But you can say, hey, let's multiply both sides by the reciprocal immediately. And that's really what we're doing each time. And some math teachers actually talk about it that way. Check this out. I have 3/3. That becomes 1. I have 2/2. That becomes 1. So those are gone. And all that's left is just that 1x. Yes, you multiply both sides by 3/2, and you get, of course, that same answer of 18. But there are a lot of different ways you can go about doing those kinds of problems. But going back to the question, do you just apply the inverse operation in the denominator? No, you multiply by the reciprocal of the item that's there. When it was 1/3 x equals 12, why did we multiply by 3? Because 3 is the reciprocal of 1/3. See 3/1? That's 3. So that gives me that again. You don't have to see it as 3/1. But that's what you're doing. So do you apply the inverse operation? No. You multiply by the reciprocal of your coefficient. You multiply by reciprocal of the coefficient. And that's the answer to that question there. And again, I'm going to 40 minutes. I can't do these things. That's why I chose only 6 questions. I can't do these things slowly. And people, if you watch this video, good for you. I hope that you got something answered along the way with that thing. But I want to cut this thing off right here. Because I want to do the live streams a lot faster. And I want to find ways that I can pick the questions so that I can answer them in a way that's kind of steadfast. But you can tell why I have to cover things in that way. There's a lot to be covered with them. These might look like simple questions, but they're not always simple answers. And I'm not saying that the answers are hard, but there's more to answering it than just the way that it is presented. Anyway, so I hope that this stuff was found useful to you. I'm going to do these kind of on a weekly basis, and sometimes there'll be less questions, sometimes there'll be more. Hopefully I can get one up this Sunday again when more questions are submitted to me, I think on Thursday or Friday. And actually, no, not this Sunday. I think it's going to be the Sunday after. And maybe, hopefully, I can get those technical difficulties resolved when it comes to the live stream stuff, so I can start getting those done on Sundays as well. So anyway, I hope that you enjoy this thing. Thanks for stepping into Mr. Robinson's virtual math classroom. And make sure that you enjoy the rest of whatever night it is that you choose to be watching your video with me. Hey, peace out, y'all.